Okay, let's get started, everybody. So again, goofy day, goofy time for class. We'll figure it out, I guess. So you guys act different, and I act different at this point in time of the day, which makes us all normal. So I'm glad we're normal still. That's normal. That's normal according to me. Some of us might be abnormal. That'd be abnormal.
I am the abnormal brain.
Me too. I like that one. That's from Young Frankenstein.
Frankenstein.
Frankenstein. Walk this way. Walk this way. I do something with that. Oh, what home? All right. We are continuing our adventure with quadratics of some sort. Okay, and I wanted you guys to kind of work on those problems the other day from 15 to 25. I'm not sure how many of you actually did, so I'm just moving on. I do have a sheet for notes, and what's sometimes silly, I don't always comprehend this. And I will tell you that I was not necessarily the most wonderful math student when I was in high school, but at least I tried. At least I sometimes tried to take notes, even though those notes might have gone home and sat in a notebook. And when I moved out to go to college, I probably threw them away. I never looked at them after. No, we probably had a fire ban in Arizona because everything was already burning. So I probably could have put in the middle of the street and would have lit on fire.
By the way, can I ask a question?
Doctor.
Have you ever been to a Burning Man concert?
Oh.
Burning Man thing in Gerlach, Nevada?
Yes.
Ooh. Yes.
Then why did you lie to us, saying that you've never done anything school exciting or going to any
Because
parties?
Burning Man's so cool.
So why would you lie to your students?
It's even better because I snuck into it. We were on motorcycles.
So you lied about
We were
doing
in
something not illegal.
We were on motorcycles. Well, yeah.
If you were in a court of law, you would already be sent to jail.
I understand.
You would have lied to us.
I understand. And Burning Man, yeah. It was, gosh, it would have been 2001. Woo! 2001.
So you went to
Burning Man.
Oh, that's the year I was born.
What?
You went to Japan.
So the Burning Man Festival, which is in Gerlach, Nevada, which is about 300,000 people that show up on this salt flat.
Yeah, no.
And
My dad's a bird.
Gerlach is in between. You got Winnemucca at the south end, Gerlach at the north end, Great Saint, and
Way in the middle of
nowhere.
No, they have this in Dallas. My dad goes to
I had friends that lived in Winnemucca, and we took their dirt bikes out to the thing.
What's the
How much is it if you don't sneak?
Look it up.
It's very expensive. I don't know.
Always stuck, yes. It was good. It was interesting. So I guess I did have a cocktail party once. All right. 3, 2, 1. Here we go. So take a look at the sheet. So solving quadratic functions number 4. Let's go to this page. So this is your second page of your notes. So just warming up. Solve for number 1. Gabe, what's my first step on number 1 to get x all by itself? Add the 6. Very good. Okay, Ben, what's my next step on solving this one?
Divide by 2.
Divide every side by 2. Okay, and then this comes to x squared is equal to 36. X squared minus 36. Now, one way we could look at it is take this and make it look like this. What did I do just now to the problem?
Move everything over.
I moved everything over. X squared minus 36 is what type of problem? Difference of 2 squares. Okay? So if it's the difference of 2 squares, I can factor x squared minus 36 to x plus 6 and x minus 6. Is that agreed?
Yeah.
So this breaks down to x plus 6 and x minus 6. And that's equal to 0. And so then I go x plus 6 equals 0 and x minus 6 equals 0. So this gives me x equals -6 and x is equal to +6. So I could rewrite this as x equals plus or minus 6. Does that seem okay so far? Now, there's one other way that I wanted to just show you how this problem would work. Everything we've worked out on it on the red is 100% correct, but sometimes you can go one step beyond, and you can do this. You can go, I want to do the square root of both sides. Now, how many answers does this problem come out to in the very end? 2. We have a positive component, we have a negative component. Remember, a square root is just a distance. Okay? So there's a positive and a negative distance. Okay? So if I were to take the square root of 36, 6 times 6 is 36, so I get x is equal to plus or minus 6. So this is a shortened version of doing this problem. Okay? Please note, by doing the square root of both sides, I got plus or minus 6. By going through and creating the difference of 2 squares, I also got x equals plus or minus 6. So there's just sometimes an alternative way of doing it. Which way is best for you? I don't know. Your mind is going to work a certain way. Okay, so problem number 2. X squared minus 4 is indeed the difference of 2 squares, which that's x plus 2 and x minus 2, which gives us x equals -2 and x equals +2. Celine, what would I have to do to this problem number 2 in order to do like I just did on the purple? What do you think? Equal to 0. But if I wanted to go make it look like this method right here, how would I change that? Where do you think I could go? Yeah, see what I've circled in purple? So basically, this step here, so if you look at this step here, which looks similar to this problem, what could I make it do to make it look like that? Real close. What did I do with the -4 though? This is x squared minus 36. Up here it's x squared equals 36. So from here to here I subtracted 36 to bring it over. From here to here I add it. So I have, yep. So this is now I'm going to add 4 to both sides. So I get x squared equals 4. And I want to take the square root of both sides. So if I take the square root, and we just saw that the square root creates 2 answers. So what is the answer to this problem? Plus or minus 2. X equals plus or minus 2. And again, this refers to that I have positive 2 as a solution, and it's also negative 2 as a solution. Good deal. Okay, so that was just a little bit different way of looking at it. So sometimes the difference of 2 squares can be done by bringing the constant value, which is the numeric value that is not attached to a letter, over by adding it, because the difference of 2 squares means you're subtracting it. And then you take the square root of both sides, and that gives you 2 solutions. Okay? Now, problem number 3, it's kind of one of those where we might have to take a look at it and try and factor it. So let's try and factor problem number 3. Ben, what is our magic number here? 10. Okay, tell me about this 10. I know that 1 and 10 and 2 and 5 are going to work, but how is that 1 and 10 and 2 and 5 going to work to give me a positive value here and a negative value here?
So you do -2 and -5.
-2 and -5, they will both work. -2 times -5 is positive 10, which was that. And -5 and -2 added together gives me -7. So, in factoring it, I have 2x squared, and I choose which one to put first. So I get -2x minus 5x plus 5. Because remember, this here has to sum up to that is equal to 0. What do I have in common right here? TJ? 2 and an x. Good, TJ threw his voice very well. Which leaves me x minus 1. And then what do I have in common on this one? Be careful. Reese. Third term's negative. What do you know I have to factor out?
5.
5 is correct. What else on it? Because that's negative. The third term's negative. What do I have to also factor out?
The x.
A negative is the correct solution. Okay, if I factor a -5 out of -5x, what do I have left? X. Good. If I factor -5 out of +5, what do I have left? -1. Good. No, TJ does. All right, so 2x minus 5 and x minus 1 is the answer factored out. I'm going to set each of those equal to 0. I think I'll bring them up here. So x is equal to, add 5 divided by 2, so 5 over 2, or 2.5, or 2.5. And then x minus 1 equals 0, so x is also equal to 1. So my solutions are 5 over 2 and 1. So those are just things that we've gotten used to. Now, I did show you a little bit different step when I took the square root of both sides. And the big important thing to realize is if I take the square root of both sides, I get a positive and a negative component for my answers, okay? So if I take the square root of both sides, I get a positive and a negative component for my answers. If the problem is already the square root of something, there's not positive and negative roots. Okay, let me say that one more time. If I take the square root of both sides in order to get x squared reduced to x, so I'm taking the square root of both sides, that creates two answers. I get a positive and a negative. Yeah. If the problem already came to you going, hey, square root of 16, it's just 4. Okay? So I'm going to go back to the very, very first slide because there wasn't much on there. If I had a problem like this, I have to take the square root of each side to get this for an answer. Is that okay? How many answers are right here? 2. If my problem has been written like this, let's say it just comes out to be square root of 16, and that's how the problem's given to you, and it says, hey, simplify this. The answer to this is just 4. I did not take the root of both sides if it already had the root taken. Okay? So if the problem comes to you already as a square root, that means you're talking about one answer. If the problem is x squared and you have to take the square root of both sides, that means you're going to have 2 answers. Okay? Yep. All right. Let's see. Need that? All right. Now, what about x squared minus 4x minus 2? If we tried to solve this, our magic number is going to be negative 2. And a negative 2, I have to multiply a positive and a negative together. And the factors of 2 are 1 and 2. Is there any way that 1 and 2 would add together to give me negative 4? No. So we have been writing that this is prime or does not factor or something like that. Do you agree?
Yes.
Okay. So we are going to start figuring out how to start solving this at the end. You still with me?
Yeah.
Yes.
All right. So now we're going to start working with some of the radicals. So we're going to get to how to find this out first, but we realize we are at prime. By the end of today, we will know how to answer, if I can spell, we will know how to answer it without just putting prime. It actually comes out to numeric values. All right. So, let's see. Before we get to our new method, we have to review some radicals. So we know some perfect squares. Of course, 1 is a perfect square, but we're not going to factor 1 out of stuff. So 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. Keeps going and going forever and ever and ever. Still with me? We good? All right, so what we want to do is we want to see if we can start breaking these down without going to our calculator and going square root 98 and finding it's about 9 point whatever. Okay? So without a calculator, and some of you are like, well, I always use a calculator. Good. If you always use a calculator, you're going to get this type of problem wrong. I'm not telling you not to use a calculator, but do not rely on your calculator for an answer because the answer is going to be an irrational answer because it's going to be a decimal that goes on forever. Okay? So we want to try and simplify these problems down. So square root of 98, okay, I can break 98 down. Now, if we take a look at our perfect squares over there, 98 times some number times another number will give us 98. And I'm hoping that one of those perfect squares works. Okay, so what perfect square looks like it might work to give us 98? 49 and 2. 49 and 2. So the square root of 49 and 2, which is the same thing as saying square root of 49 times the square root of 2. And the square root of 49 is what? 7. Should I have plus or minus on this problem?
No,
No, why not?
because there's no X.
There's no x. I haven't taken the square root of both sides. It was already given to us, the square root. So the square root of 49 is 7. So my answer to this problem is 7 root 2. And that is an exact answer. Okay? Where does 7 square root 2 exist? 9 point something. Where exactly? At 7 root 2. But where 9 point what? 9 point repeating decimal on and on and on forever and ever and ever. Why do I know that? Because square root of 2 is an irrational number. I never can find the fraction that's equivalent to the decimal. Okay? All right. Problem number 2. Problem number 2. I have 2 times the square root of 18. So whatever comes out of the radical, I have to multiply by this 2. So this 2 is the little brother you got to bring along with you to the mall. And you're like, really? How cool is that? So now I want to look at 18.
No.
18 is one of those perfect squares times another number. 9 times 2. Okay? Now those of you sitting there going, what about 3 times 6? Good. Those are factors. But 9 and 6 are 3 and 6 are not perfect squares. So I'm looking for my largest perfect square. So I have 2 times the square root of 18 is 9 times 2. Agree?
Yes.
Is that 9.2 or is that 9 times 2? 9 times 2. Okay? So I also know this, that 9 square root, or 2 times square root of 9 times the square root of 2 is how another way to write this. What's the square root of 9? 3. Do I write plus or minus? No, I didn't have to take the square root of both sides. It had already been done for us. So what is the square root of 9? 3. So this is now going to become 2 times 3 times square root of 2. Now, you have things outside. What's 2 times 3? So my answer is 6 square root 2. Okay? Still with me? Last one of our examples. 500 does work as one of our perfect squares times another number. What do you think? And some of you are like, dude, it's like 25 times 20. Good. 25 is a perfect square. But there's a bigger perfect square that works. 100 works. Okay? So square root of 500 is the same thing as the square root of 100 times 5. Now, do I need plus or minus on this problem? No, I haven't taken the square root of both sides. Okay? So the square root of 100 times 5 is the same thing as the square root of 100 times the square root of 5. Still with me? What is the square root of 100? 10. So my answer is 10 square root 5. And again, guys and girls, this is an exact answer to this problem. Few things to kind of consider. You guys have heard this in science, I believe. Something called a margin of error.
Yeah.
Okay?
Yeah.
The nice thing is an exact answer doesn't have a margin of error. If I were to figure out what square root of 500 is on my calculator, your calculator is going to have a certain margin of error. Now that certain margin of error might take place 12, 13, 14 decimal places out. So it's very little, right?
Yeah.
But it's still nicer to carry through something being root 5, which is square root 5, than it is going, oh, that's 2.161134247, whatever. No, I'm just making it up. But it is 2 point something, I know that.
Usually 2.4.
Usually. Sometimes. On every other day, that's not Thursday. But today's not Thursday, dude. All right. So let's take a look. We are going to go to the quadratic equation, and it turns into the quadratic formula. So a few things about the quadratic formula. You see the a, b, and c on the quadratic equation?
Yeah.
And then if you look at the quadratic formula, do you see a, b's, and c's down there? Yeah, they also have 2, and they have a -4 in there too, right?
Yeah.
So this is a formula that you need to know. It looks like we have a video we can go to. I'll go to it eventually. Okay? It might be an exciting video because it must be a math video. We all applaud that. So, you guys know, do you remember the little song as a younger child, Pop Goes the Weasel?
Yes.
Okay? So So, some of you unfortunately didn't, get that song. If not, you can take a look at it later. But this is how you remember. This is how you remember the quadratic formula. And you know I'm not afraid to sing in front of people, so I'm singing.
No.
You ready?
No.
Ready?
No.
Ready?
No.
Ready? Here you go.
Do it.
X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Woo! It worked! It worked!
I don't want to know the quadratic.
X is equal to negative b plus or minus square root b squared minus 4ac all over 2a.
X equals negative b plus or minus square root.
Square root.
Square root.
All right. Let's see. Let's see what this is. I'm just going to do a copy paste right now.
Do you not know how to do algebra?
Oh, I do. They just didn't have it listed like that.
Is this not your slide?
No.
You didn't make this?
No.
Oh, cheater. You should fix that.
If you
Can you tell
cite
us
your
what-
sources.
Nope.
Cheater. We need to give him an F. He didn't cite his sources and he also cheated.
I did.
You can do just Control C, Control V.
I know. Here we go. Woo! This should be good.
Yay!
Oh, yeah! We did it! We did it! Alright. Good stuff, good stuff. So, we can have songs that go with it. Some of you are talking way too much. So, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. You'll hear people during our tests and quizzes start singing it. You're like, dude, stop! Okay. I'm pretty sure you can probably download that song, use it,
Q-cubes.
remix it. I know there's a version of it that goes with Gilligan's Island. I'm sorry, I don't know it.
It's like
What?
dubstep.
There's a Gilligan's Island one?
A version, yeah. I leave that up to you for later today.
I'm gonna look it up.
All right, here we go. So x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. All right, so let's see me. Ready? X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Okay, so here we go. Here we go. What is my a value in accordance to this? It's not x squared. X squared is x squared. What is my a term? What is? It is not x squared. It's attached to x squared. It is 1. Thank you. What is my b value up here? Negative 4. And my c value? Negative 2. So, we know that x is equal to negative b plus minus square root b squared minus 4ac all over 2a. That we are going to take a, b, and c and plug back into it. Okay? So, things that I know. Going along with this problem, I have x is equal to negative b. What's b? What's b? Negative 4. Plus or minus square root. What's b? What's b?
Negative 4.
And we're going to square it. Minus 4. This is a constant. What's a? 1. What's c?
2. Negative 2.
Negative 2. All over 2a. What's a? 1. Good. You guys tried hard.
Yeah.
All right. So let's start fixing this problem. Let's see if we can figure it out. What do we know about this?
Positive.
It's positive. What's this?
Negative 8.
No, positive 16.
Positive 16. Good,
Oh,
Mac.
squared.
How is it positive?
Negative 4 times negative 4. Negative times negative is positive.
Oh.
All right. Negative 4 times 1. Negative 4 times 1. Negative 4 times 1. Negative 4. Negative 4 times negative 2.
Hey.
Positive 8. Guys and girls, take note up there. We just switched signs. TJ, I'm glad you're paying attention. It's real respectful.
I'm sorry.
Okay? Please take a note up there. A big error that takes place on the quadratic formula is you don't carry the signs through. Notice I went -4 times 1. I got -4. Now what's -4 times -2? It's positive 8. It changed signs up there. Okay? All over 2 times 1. What's 2 times 1? 2. Okay? So let's start simplifying this. Do the math underneath. What is 6 plus 8?
16 plus 8 is 24.
16 plus 8 is 24. So I get 24 all over 2. Okay? I want to break down the square root of 24. Okay? So I know my perfect squares are 4 and 9 and 16 and 25. And we can stop there. What's going to work? What times what? One of them being a perfect square gives me 24. 3 times 8. Okay, where's your perfect square?
4 and 6.
4 and 6. Okay? Ready? 4 plus or minus square root of 4 times 6.
Wait,
All
both
of
of them have to be
Just one of them. Just one of them.
Wait, so we can use
9 times what gives me 24?
9 too?
Okay. All right. So this is going to break down a little bit further. So I get 4 plus or minus square root 4 square root 6 all over 2. Square root of 4 is what? 2. 4 plus or minus 2 square root 6 all over 2. Almost done.
We still have to break that down.
I can reduce the fraction. Yeah. Okay, here we go. Okay. This 2, does it go into this and this?
Yeah.
Does it go into under the radical sign? No.
No.
If I have the square root of 7 over 3, that 3 does not go into the 7 because the 7 is out of the square root. All right, so 2 reduces here. I get 2 plus or minus 1 square root 6.
Wait.
Do you think that 1 needs to be there?
Wait, we can just do it like
Yep.
So why
that?
can't
You
we
can
put it
factor
in
that down into more things.
Huh?
But you can factor that down into more things.
6 breaks down to 2 and 3. You're absolutely right, but 2 or 3, neither of them are perfect squares. Right? Okay, so the quadratic. So, guys and girls, if this was a parabola, this would cross the x-axis at 2 plus square root 6 and 2 minus square root 6. Where the heck is that on the x-axis? But where? At 2 plus root 6 and at 2 minus root 6. But where's that at? Well, the square root of 6 is 2 point something. So you have 2 plus 2 point something and 2 minus 2 point something. Is that exactly where it crosses? No. Square root of 6 is irrational. You can't make a fraction out of it. Okay? Your exact answer is 2 plus or minus square root of 6. So the quadratic formula allows you to take those problems that were not factorable originally, and it allows you to break them down. Okay, the quadratic formula works on every quadratic equation you come across. Those that are factored all the way, it's great because the square root is a perfect root all the way. So you might have 3 plus or minus square root 25 over 7. Square root of 25 is 5. 3 plus 5 over 7. 3 minus 5 over 7. Done. So it comes out. So if it was factorable, the whole quadratic formula would have factored out for you. Okay? Meaning, if you were able to factor the problem, this part right here, when I did the arithmetic underneath the radical sign, under the square root sign, it would have been a perfect square. It would have been a 4. It would have been a 9. It would have been a 16. It would have been a 25. All together. Are we good so far? All right. So, looks like we are going to do one that does work. Okay? I will tell you that this problem will factor down to x plus 2, x plus 3. It's equal to 0, so that's x plus 2 equals 0. So x equals -2. X plus 3 equals 0. So So x is equal to -3. My solutions to this problem are x equals -2 and x equals -3. If I had graphed this parabola, it would cross the x-axis at -2 and at -3. This problem worked out nicely because it factored. If I use the quadratic formula, which is x is equal to -b plus or minus square root b squared minus 4ac, all over 2a. Couldn't write that faster. What's my a value of this problem? 1. What's my b value of this problem? And my c value of this problem? Okay, that's my a, b's, and c's. You still with me? Make sense? Okay, can I extend the page?
Yes.
Let's do it. All right. It's right there. It just moved up. He said, damn it, but then there wasn't an N at the end of damn. He was talking about like a damn road.
Sorry.
Oh my gosh, Reese, you're good, don't you? All right, you okay, Reese, or do you need me to go back down? All right. Minus squared b squared minus 4ac all over 2a. Hang on, did that work? X is equal to, hey, why is it -5? Why is it -5? Why is x equal to -5?
Oh, because it's
Because x is equal to -b and b is equal to 5. Teacher writes the song as a nursery rhyme. And then we will hate you.
Wait, so
Oh, become positive. Okay. All right. Shh. Still working. Work it. All right. Shh. Let's do the arithmetic. Okay. So I know I have equals -5 plus or minus. Let's do this math. 5 squared. 25. Thank you. -4 times 1. -4. -4 times 6. -24. Love it. All over 2 times 1. Still with me? All right. Still doing the math. What's 25 minus 24? 1. So I get -5 plus or minus square root of 1 over 2. Now, I'm pretty sure you can tell me what the square root of 1 is equal to. 1. Good. So now I'm going to get -5 plus or minus 1 all over 2. Where'd the radical go? I took the square root of 1 and I got 1. Square root of 1 is 1. -5 plus 1. -5 plus 1. -4. So I get -4 over 2. -4 over 2 is equal to what? -2. Oh, got one of them. All right, -5 minus 1. -6. -6 over 2 is -3. My answers here when I factor were -2 and -3. When I used the quadratic formula, I had a perfect square underneath the radical. We came up with the exact same answers. Thank goodness. Man, oh man, oh man. I feel pretty good. I don't know about you guys. Yeah, dude, he just won't shut up. He keeps going.
Wait, can I see the equation again? Just up a little bit.
Oh, I'm excited. Let's see. How many more slides do we have? 3. We have 3 more slides. Can I do it? I don't know. You're the teacher. You should be able to. Here we go. Here we go. Here we go. Here we go. I want to factor this. It's equal to 20. I want it to equal to 0. If we factor it, what should I do with that 20? Minus 20. Good. So we're going to modify this to look like this. Still with me?
Yeah.
Still there? It looks like I have a greatest common factor. What's my greatest common factor of 2? -6, -20.
-4.
2. Thank you. And that's 2x squared minus 3x minus 10. Okay? The factors, it's 12. The factors of 10 are 1 and 10 and 2 and 5. Is there a way that one of those could be positive, one of those could be negative, that would give me negative 3? I will tell you it's going to be x minus 5 and x plus 2. If I did this math, I get negative 5x, positive 2x gives me negative 3x, get negative 10. So my answers to this problem are negative 5, so x equals 5, and x plus 2 equals 0, so x equals negative 2. I get positive 5 and negative 2. Do I worry about the greatest common factor when solving? No. All right. So I know that x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. What's my a value? What's my a value of this? 2. What's my b value of that? Negative 6. What's my c value of that? Negative 20. Awesome. Here we go. Shh. We ready? 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 Here we go. X is equal to negative
6.
negative 6 plus or minus square root. What's squared?
6.
Negative 6 minus 4. What's a?
2.
C.
Negative 20.
All over
Negative 6. Negative 2.
2a.
Oh.
Yes? All right. What do we get here? What do we get there? Positive 6 plus or minus square root. Negative 6 squared. Negative 6 times negative 6 is positive 36. Good try. All right, hang on, I'll get you, Ash. Negative 4 times 2. Negative 8. Negative 8 times negative 20. Negative times negative is? Positive. 8 times 20.
160.
160. All over what? 4. Shh. Almost done. Come on, guys, girls. Stick with me, please. 6 plus or minus the square root. What's 36 plus 160?
36 plus 196.
196. Do you all know that 14 times 14 is 196?
Do you know that?
Do you know what the square root of 196 is then?
14.
14. Excellent. There you go. 6 plus or minus 14 over 4. All right. Hang on. 6 plus 14. 6 plus 14. 6 plus 14. 6 plus 14.
6 plus 14.
20. 20 over 4.
5.
6 minus 14. 6 minus 14. Negative 8. Negative 8 over 4. Negative 8. Negative what? 2. I got answers of 5 and negative 2. Hang on. 5 and negative 2 are my answers. 5 and negative 2 are my answers. It worked. It worked.
Like, hold up.
Holding up.
For 5, it's 6 plus 14 equals 20, so 20 over 4 is 5.
And then 6 minus 14.
Minus, okay.
That makes sense, Reese?
Yep.
Sweet. Do we have one more problem? 2 more problems? Do you have 2 more? All right, your turn. Your turn. You have it on your page. Here we go. Try it. Try it. If it doesn't factor, write down your ABCs. Hey, does ABC have X's involved with it? No. A, B, and C's are the constants. They are the coefficients. They are the numbers that are in front of the X's. Shh. Ashley, you had a question and I haven't answered it yet.
When you were rewriting it in green, how do you know it was like -20?
This one?
Yeah. Like it's 2x squared minus 6. How do you know it's -20?
Oh, because I want this to be 0, so I want to subtract 20 from both sides. So then it becomes equal to 0. Okay?
Where?
Yep. That's what I got for my A and my B and my C. And that's the quadratic formula. I know the sing-song song, which is always good to know the sing-song song. Ooh, you got marshmallows? What do you think? Am I plugging it right? Does mine look like yours?
Yes.
Okay.
Close enough.
Close enough. No way, Jose. What about that? Where'd the 16 come from? Where'd the 16 come from?
4 squared.
4 squared. Where did the positive 24 come from?
The 4 times 1
Negative 4 times 1 times negative 6.
Yes.
Is 40 a perfect square?
No.
No. 36 is, and 49 are. So it's somewhere in between the two of those. So I know that 4 and 9 and 16 and 25, 36 and 49 all work. So what should work for 4 and 10? I like it. So negative 4 plus or minus square root of 10 times 4 over 2. How does that break up? Square root of 10, square root of 4. What's square? Which one breaks up, the 10 or the 4? The 4. You see what I just did there? Square root of 4 is 2, brought it out front. Can I reduce this fraction? Does this, and does this have anything in common?
Yes.
What? 2. So I get negative 2 plus or minus. I don't have to put the 1. There's my answer. So this one that did not factor now comes up with an answer. This one that does not factor comes up with an answer. So x is equal to this. If this had been a parabola that we were graphing, it would cross the x-axis at 2 plus root 10, or negative 2 plus root 10, and negative 2 minus root 10. Last one, it's on you. Last one on you.
Wait, can you go back really quickly?
Real quick. Real quick. Yeah, buddy. Last one. 2x squared minus 4x plus 3. Do it. Do it. Double check that your ABC looks like my ABC.
Oh, ABC. It says yes, 1, 2, 3.
All right, Jackson 5. Love it. You gotta love that we bust out a song in here.
I can hear everyone remember that song. No, you did really good. Thank you.
That's how I plugged it in. When the bell rings.
But when does the bell
13.
ring?
12, 13.
Okay.
That's what I'm coming across so far. What do you think? 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 I need help here, though. Don't hold that against me. What is 16 subtracting 24? Ooh. 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 So. Uh-oh. All right. From here on out. From here on out. From here on out. If you see a negative under the radical, once you've done all the arithmetic, if it happens to be a negative, I want you to see this. Ready? Eyes up here.
Imaginary.
Imaginary. Because the letter I, written like that in math, stands for the square root of -1. And if you have I squared, it gives you -1. And if you have I to the third, it becomes -I. And I to the fourth becomes 1. And then it repeats. I to the fifth, the same thing as I to the first. I to the sixth, same thing as I squared. Oh my gosh, we have I. So, without too much explanation, if you have a negative under your radical sign, then write it as with an I. Now, kind of ignoring the I for right now, how can I break 8 up into a perfect square and a not perfect square multiplied together? I think I heard someone say 4 times 2, but I might be wrong. Still with me? Is the I still there? Yes? Which means do you agree with this? What is the square root of 4? 2. Is the I still up there?
Yeah.
Yes, it is. What does this and this and this all have in common to reduce to? 2. So, is the I still there? It's still showing up. Yes, thank you. Mac, you got the word today for paying attention. Thank you. All right, so this problem doesn't indeed have a solution. It's 2 plus or minus I root 2 all over 2. I stands for it's an imaginary number. An imaginary number means part of the complex number system. The complex number system is a very large number system, which includes all of the rational and irrational numbers that you've ever dealt with in your life. And now we are incorporating all negatives under the square root. Whoa. Yeah, baby. We just expanded our universe. Okay. Yeah, it just reduces like reduces the fraction. Okay, so guys and girls, if we had graphed this parabola and graphed it, this parabola would not cross the x-axis. It would not cross our horizontal plane. Okay, but it does have a solution, which happens to be an imaginary number, which is okay. An imaginary number in the imaginary number system, it's big. Okay? Holy moly. So, if you have a square root and there's a negative under the square root, the negative goes bye-bye, and it becomes I right outside.
Nice.
Yep. Your project for tomorrow. So, a few things. Schoology.
Tomorrow?
There are 2 items up there. I believe it is number 9 and number 10. I think that's what it is. So get those going.
When's number 10 due?
Saturday next week.
Okay.
And then our assignment, in which I will be marking off on Friday. This will be points. Our assignment is worksheet number 4, which is page 101 and 102. Anyone need a picture of it? It's going to be in the basket right here. There's a front and a back to it. I think you can do it because you all know now at this point that x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. Woo!